Within the object rendering aspect of the project, I created and rendered several objects utilizing VBOs to read and contain the information for every single object. Firstly, to utilize the scene resources, I needed to create for every single object an AI scene, a constant AI scene. So here you can see I've made my tank, my enemy tank, and so on, with the corresponding label. Then I had to declare the texture that I wanted to use for each of these objects. Then, using the scene VBOs, I contained it all. So here you can see the tank, enemy tank, and radio are all contained in a scene of VBOs. Now if we go down within the code, here is where I would make my AI imported model. So for instance, this is the tank, so I said the tank is equal to the imported model with the string of the location of where the OBJ model for the tank is. Then underneath it, the texture with the location of the texture for that model is. I did this for all objects used within the gameplay. Then, as you can see, I've here shown the scene VBOs and the AI of that. Then if we go further down within the code, here is where I actually implement the position, scale, and rotation. First, I do bind texture to show the texture, and then enable GUL texture 2D. Using the GU matrix 4, I then do the translation matrix, which is the location, and then the scale, which is obviously how big the object and model is, and the rotation for what angle it's turned to. For this example, actually I'll do the second example for the enemy tanks. I've put here the location axis values, and then done the scale, and then again a rotation. And at the bottom of each one, I have said that corresponding model is render. So then that is drawn into the scene. Also within each object, there would need to be an actual differentiate between them. So for instance, here we have model matrix 2 as well as new T2. This is not the case if it's a copy of the previous model, such as the tanks, as they're all the same. But then in a new object, you'll need to do this, so you're not calling the same values. All of these objects are stored as VBOs. As I said above, using the scene VBOs is what allows me to store all this information. Quickly, I've come back to the section to say how all these AI areas are where all the AI processes are conducted. So this is where all the vertices are joined, all the calculations for the normals are here. All the AI processes to import these models are conducted within these AI with the corresponding name here, A level. Next, within the lighting aspect of my project, I used the vertex shader attribute bindings to create a location where I could make my vertex lighting. I used this to base off my fragment shader lighting. So within the mesh shader FS, I declared a pixel normal for the fragment lighting. I then calculated the position, length, direction, and normalized the distance. I then calculated the orientation based on the distance value of length D. I then did Lambertian and returned the final brightness for the light source. So next, in the void main function, I calculated the length as well as the L color, so the color, and the LK, which is attenuation. I calculated the color, as you can see here, using RGB format, and I wanted my colors to first have one light source as a base of a nice orange to go with the sand and everything to make the overall map light up, and then I wanted a secondary color of a really bright light source and located that quite far away, as I wanted that to be the main sun-like light source of the game. So when the player turns around, some areas are lit brightly with the sun light source. Here is my transparent finish line object. First I use GUL enable and GUL blend, and then GUL blend function for the alpha, and GUL depth mask and set it to false. I used all these to control the parameters of the blending for source rendering. I used this to render the object color, or the texture in this case, with the alpha values. This allows me to change the overall intensity of the transparency. I did this within the basic texture.fs. Here is where I can change the transparency intensity using textcolor.a. Next, within the audio sound setup, I used an ALC device to open the device and get the context, and then created a buffer object. This buffer object had my sound data and the format and data chunk. I then used my sound data in the new GUR riff model to locate the tank sound I wanted to use, the sound file. This was all generated within the buffer object. I then, lower down, put the position, velocity and direction that I wanted this sound source to be in, and attached the buffer to this source. I then set up a listener for the main camera, so that when the game is opened, the main camera will present this audio and you'll be able to hear it. And then at the very bottom, just to make sure the sound is playing, I've enabled the source. Finally, with the player interactions, here's how I created it. I made floats of the player X, Y, and Z axes and set them to what would suit within my scene. I will use these later. Next, I went down, and as you can see here, I said, using if functions, if A key is down equals true, if D key, W, S, Q, and E key are true, the corresponding movement happens. So with player Z axis, if the A key is down, it will go up by 0.3 F, and then after it's been pressed, it's then false, which stops the movement from happening within the game after you've pressed it. Same with D, but more it's corresponding to what would happen when you press D, which would be minus 0.3, so the opposite way to A, as A and D are left and right. And this is all the same for the corresponding keys. And using these if functions, I'm able to do that upon input within the gameplay. Next, to declare what the key is, in this void key down function, I've said if key equals and put the actual key example within the if function and said what happens when those in particular keys happen. So when W, I'm declaring all of these keys to have the function. When W is selected, W key down is true for this example. If you go back up, within this I've stated W key down equals true. So once the W key is selected, as it says here, W key down will equal true, meaning that the movement of that object will also be true. To complete the movement within the gameplay, I need the camera to follow the object. So here within the display void function, I've got the main camera with the projection transform divided by the main camera with the view transform. And here I've said the translation matrix, so the position of the player X, player Y, and player Z are divided by the view transformation of the camera, meaning that wherever the player goes, the camera will follow.